So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mascot this side. So this is the lecture number 19 of the binary tree series. The problem is actually very simple. The problem says kth ancestor of a node. The kth ancestor of a node. For example, in the given binary tree, this is obviously the root, right? Suppose the first test case that has been given to you is that the node is 4 and k is equals to 2. What does that mean? What does that mean? It means simple that you have to find the node 4 first. So this is my node 4 and the kth ancestor means two ancestors above, that is 4. First ancestor is it, that is its parent, and the second ancestor is its grandparent, 1. Right? 4, 2, 1. If the k would have been 1, if the k would have been for the same node for k equals to 1, what would have happened? You would have found the 4 value and you would have seen the first parent, that is 2. So your answer would be 2. So in the first case, the answer is 1. In the second case, the answer is 2. Now, what if in the third test case, 4 is given to you as node, but k is given to you as 3. K is given to you as 3. Okay. So if you see from 4, you will go to its parent, 2. You take one transition. From 2, you will go to its parent. You take second transition. For 3, you will see here that it is a null node. 1 is absolute parent, 1 does not have its own parent. So you will have to return -1. This is what the question says. The question says that in the path of the node to the root, tell the number of ancestors. That is, this is the first ancestor, second ancestor, third ancestor is -1. Third, fourth, fifth, all of them are -1. You just have to determine the value of the ancestor. In this case 1, in this case 2, in this case -1. Hope you are clear with it, right? Hope you are clear with it. Now, the question is how to approach the code. How to approach the code. So the problem is simple. First, to find the kth ancestor, I need to set where is my node. I need to set where is my node. I have to locate my node. I have to locate my node. So the algorithm says locate my node. Locate my node. Now, we have been studying binary trees from quite a time now, and locate my node, I only have one thing in my hand, I can traverse. So traverse to find your node. Traverse to find your node. Right? So what is actually happening is you're standing at 1, you see 1 is not equals to 4. You go to 2, you see 2 is not equals to 4. You go to 4, you see 4 is equals to 4. But what if 4 was actually present here and it is 5 actually? Okay, so if 5 is not your node, so what will it return? 5 will say that I am not your node, so return false. That I am not your node. 2 will now go to 4. 2 will say it is 4, so it will return true. It will return true. But what should I do of the 2? If I know that k equals to 2, if I want to get k equals to 2, I need to skip this 2 and went, like I have to return this true and I have to take this value, right? Are you able to understand my point? If I'm returning true from here, but 2 is not my answer, 2 will say I am getting a true, but I am not the answer. I need the kth ancestor, that is, I need the this value, this node. So what should it say? It should say that I will also return true, and now this will be my answer. But how should I do that? How should I manage that 2 is not my answer and 1 is my answer? How should I do that? Okay, so let us see. We have been given k, right? We have been given k. Can I say that k actually means skipping some values? Skipping some true. Skipping some true. What I'm actually trying to say is for the tree 1 connected to 2, connected to 5, connected to 4 here, and 1 connected to 3 here. Suppose I have to find the node 4 and k equals to 2, that is, I need to find the second ancestor. So what is actually happening is I went to 1, right? I went to 1. Suppose 1 goes to 3. 1 goes to 3. 3 will actually return false. 3 will actually return false, right? And k is equals to 2 in my hand right now, right? Now 1 will go towards true. 2, sorry. 2 will go towards 5, right? 2 will go towards 5. Obviously 5 is going to return false because it is getting two null nodes which are returning false along the way, right? Now what will happen? As soon as it returns false, 2 will go towards 4. When it goes towards 4, 4 is going to return true. 4 is going to return true. So 2 gets one false and one true. True doesn't matter if the false is there or not. True has some attention to true, right? As soon as it encounters a t value, a true value, what will it say? Is my k equals to 1? Is my k equals to 1? Am I the node it is looking for? No. So what do? I will decrement it. So k will now become 1. K will now become 1 and it will also return true. It will also return true. As soon as one gets t value, one will say, what is the K? What is the K? K is 1 now. Okay, so I am the value. So I will take an answer value which will say answer equals to 1. I will set it, right? And when this solve function or when this helper function returns its value, I will say answer equals to 1. Answer equals to 1. Let us try it on one more example. Suppose the tree given to you is 1, connected to 4, connected to 5, connected to 6, connected to 7, 8, and 9, 10, 11, and here it is 2, 5, 6, right? Not 5 and 6. Let us take 12 and 13, 12 and 13, right? Let us see that values are not repeating. Let me rub it and write it again. So it is 12 here, 13 here, right? Let us see if it works for it. Suppose I want to find the node 9. I want to find the node 9 and I want k equals to, let us say 3. Let us say k equals to 3. So what is my answer gonna be? 9 is this one, first ancestor, second ancestor, third ancestor. My answer should be 4. We know that answer should be 4. Let us see if we get that. Okay, so some of the things we have to initialize. We will call for the function. We are standing at 1. K equals to 3 right now, and our answer equals to -1. Initialize your answer as -1 in the global scope, right? You get to 1, you say go to 4. You go to 4. Okay, 4 will say go to 6. 6 is gonna return false. Why false? Because both of its children are null, so they are actually gonna return false. So 6 will also return false. 4 will say, okay, I'm getting false from his side, but let us see the 7. 7 will say, okay, 7 is also not equal to 9. 7 will say, let me try it to 8. 8 will say no. 9, yes. As soon as 9 returns true, you see that I'm not even visiting 10, 11. Why? Because I found the value. So why should I traverse downwards? Why should I traverse downwards? Why should I traverse downwards if I got the value? If I got the value, right? As soon as 9 will return true. As soon as 9 returns true, 8 gets true from one end. And because it gets true from one end, it says k is not equals to 1, so I will decrement it once. Okay. And because I'm getting 1 true, I will also return 1 true. Now 7 gets 1 true. As soon as 7 gets 1 true, 7 will say that, hey, I'm not k is not equals to 1 right now, so decrement it. Okay, and again I will return true. As soon as 4 gets true, 4 will say, hey, k is equals to 1, so answer gets updated. Answer is now 4, and now decrement it 0. K will say 4 will say decrement it after assigning it to the answer, and now go to 1. Return 1, true to 1. 1 will again say that it is true, but k is not equals to 1, so decrement it again. I don't care about k because I have my answer, right? I have my answer. So I don't care whether k goes to minus infinity. I don't care about that, right? Okay, it gets to true. Now, if you see, as soon as it goes to true, this tree is still unexplored. This tree is still unexplored. But do I need to explore it? But do I need to traverse it? Is it traversal needed? My question to you is this traversal needed? The answer is strictly no. If I got the true from one side, why should I actually travel to the other side? I know the answer lies here, right? So what is actually happening is we are actually looking for the value of the node, look for the current node, go to left child, go to left child. If this is the first condition, this is the second condition. If one is incorrect, then go to 2. If 2 is incorrect, then go to 3. If sorry, go to left right child. So I hope you are getting my point. If this is wrong, like if t is false, for the case of when 9 we encountered, we didn't even scroll to 10 and 11, right? So look for the current node. If 9 equals to 9, return true. Otherwise, go to the left cell. For example, here 1 was not equals to 9, so return 4, right? Went to 4. Now go to the right side. If left is also not returning true, then go to false. For example, here when 4 was getting to 6, 6 returned false, then only it went to true, then only it went to 7, right? Okay, so the code is actually very simple. Looking for the current, that is root. Go to the left, go to the right. What is this traversal known as, guys? First root, then left, then right. This is a simple pre-order traversal, and our statement that binary tree is solved by traversals is actually very correct. You just have to explore which traversal. You just have to solve which traversal, right? And your problem will be solved. So I hope you're clear with it, and we can write the code for it now. So here is the coding section. But before starting with the code, I would like to request you to please subscribe to my channel because it really motivates me, right? So as discussed, what we will do, we will just say int answer equals to -1, right? And now just call the solve function for the root k and node as it is, and send it. Okay, and then return your answer, right? Send answer here only by reference, right? Now what you have to do now, it is void type function, so void solve taking a node star root int. Now k has also be to send by reference, or it is also a bool type function because we were turning true and false, right? So bool k has to be sent by reference. Why reference? Because for 4, when you were coming back, first it was 3, then it was getting decremented for the above nodes as well, right? Okay, so int node and int and answer, right? Because we have to change the answer concurrently. Now if root equals to null, return false, return false. If root value equals to node, if root value equals to node, return true, return true, right? Otherwise, if solve for root left with k node and answer exactly same, if it is returning true, then if k equals to 1, then answer equals to the current node, that is root value, not root value, root data, right? Root data, and above also it is root data, right? And now just decrement your k whether or not it is equals to 1, right? If else if solve for root, also you have to return true as well, return true from here only. You don't have to explore the right side, right? Root right k node answer, then again if k equals to 1, answer equals to root data, and then k minus minus, and also return true, return true. Otherwise, if all these conditions are not working, return true is not working anyways, return false, right? Because you have explored all the cases for the current node. Let us try to compile and run it. Hope it will work fine, should not give any error, I guess. It is working fine for the sample test case, and I think it will work fine for the backend test cases as well. It is running and running very fast. Okay, and getting submitted. So thank you for watching. Hope you like the video and make sure to subscribe to the channel. Thank you. Have a nice day.